Welcome back, Anatomy and Physiology students. This is Unit 1, Part 2, all about chemistry. Now, why are we talking about chemistry and anatomy? Well, chemistry is everywhere in the body. When we take the food that we eat and break it down for energy and for muscles, that's chemistry. We also, when we take medicine, that would be a form of chemistry, right? Basically, any type of reaction that happens in our body would be a form of chemistry. There are thousands of different chemicals in our bodies, and all of these chemicals do all sorts of different things. They help with metabolism, they help with movement, they help with digestion, they help with breathing, respiration, they help with pumping your heart and sending nerve signals through your brain and through your nerves. All of these processes that happen in our body involve some sort of chemical reaction, some sort of chemistry. So this this video is all about the basics of chemistry and a big refresher of some things that you learned in 10th grade. So the first basic I want to talk about is matter. Matter is just basically anything that has mass. And if you remember, matter could be in 3 states: solid, liquid, gas. Of course, solid would be like the food that we eat and the muscles and the bones and the cells that make up our body. A liquid would be like the plasma in our blood or the water that we drink. We also talk about gases when we talk about carbon dioxide and oxygen. We talk a lot about those 2 gases. We also briefly talk about physical and chemical changes. Remember, a physical change is when the substance stays the same, however it changes states, either by bending it or cutting it or breaking it down, but it's still the same substance. That's the key thing about a physical change. Sometimes that substance may just change states, like going from liquid to gas or gas to solid. Whereas a chemical change is when the substance literally changes its chemical formula, when it's a completely new substance. We talk a lot about chemical changes in our body when we talk about breaking food down and digestion, and then taking the food that we broke down and bringing it back up to something different. Maybe the muscles for your body, or the bones, or energy, or glycogen. All those metabolic reactions, those are types of chemical changes. Again, these are all should be refreshers for you from 10th grade. Again, the atom is the smallest particle of mass. It's made up of 3 things: protons, neutrons, electrons. Protons have a positive charge, neutrons have no charge, electrons have a negative charge. And if you look at a periodic table, you have all the elements that we know of, and the way they identify elements is by the number of protons, and the way they list them on the periodic table is that the number of protons an element has is equal to the number of electrons. It's neutral. And that an element, the way it bonds and how it bonds is based on its number of electrons in its outer shell, its valence electrons. And elements that have the same number of atoms, the same number of electrons in its outer shell, the same number of valence electrons, bond the same, act the same, look the same, kind of do the same thing, fall in the same group, okay? Now, when 2 or more atoms bond together, that's called a compound. And if an atom has either gained or lost an electron, then that's considered an ion. I want to stress this word ion because we're going to talk a lot about ions throughout the year, and I want to make sure you understand this word. An ion is an atom that's either gained or lost an electron. Positive ions are atoms that have lost an electron, lost a negative particle, so they are now positively charged. A negative ion is an atom that's gained an electron, so it's gained a negative particle, so it's now more negative, okay? Most atoms in our body do not sit in the neutral state. Usually they're in an ionic state, such as calcium, sodium, potassium, hydrogen. We talk about these ions over and over and over again throughout the years. So when we talk about the word ion, you should recognize that it's basically any element that's gained or lost an electron. There's also different types of chemical reactions that occur in our body. When we take two substances and bond them together, that's called a synthesis reaction or an anabolic reaction, when your body is building up new muscle, building up new skin tissue or bone. That would be a synthesis or anabolic reaction. A decomposition reaction would be the opposite of that, when your body breaks down particles or to a smaller state, or a catabolic reaction. Ideally, a healthy, normal adult would, their anabolic reactions and their catabolic reactions would equal. That's what metabolism is. The amount of things that they're building up equals to the amount of things that they're breaking down, so that a healthy person would have the same mass, same weight, right? Other types of reactions that occur in our body: single replacement, in which the molecules just switch places, or a double replacement where two molecules switch places. Another key concept that I want to refresh with you is the differences between acid and bases. This is another concept that we're going to touch on over and over and over again in anatomy. Acids are substances that tend to have lots of hydrogen ions, H+ ions, right? And the more hydrogen ions a substance has, the more acidic it is. Acids have a pH less than 7. Please memorize that. You should know that by now. Anything less than 7 is an acid. Whereas bases tend to have lots of hydroxide ions, OH ions, and bases have a pH greater than 7. Really, in our body, in anatomy, you don't see any substance that has a neutral pH. Really, distilled water is the only substance out there that has a neutral pH. Everything else is slightly basic or slightly acidic. If you look at this diagram we have, saliva, your spit, is slightly basic. Excuse me, saliva is slightly acidic, and your blood is slightly basic. Again, we'll be touching on the different acids and bases in our body over and over again throughout the year. Now, our bodies are made up of 4 different substances, primarily: oxygen, carbon, hydrogen, nitrogen. Probably the most important substance out of those is carbon. Carbon is such a unique atom, a unique element, because it can form so many different states. If you think about it, diamonds are made out of carbon, and oil is made out of carbon, and you and I are made out of carbon. There's so many different things carbon makes up. It's pretty amazing. It can do so many different, make up so many different substances. So basically, most of our body is just a combination of oxygen, carbon, hydrogen, nitrogen. If you think about that, that's pretty amazing. Our brain, our heart, our arms, our legs, our stomach, our gut, everything is just made up of a combination of these 4 atoms. It's pretty amazing that our body can do so many things just from 4 small, tiny atoms. Another key concept I want to make sure you understand is the difference between organic and inorganic. And I know that when I say the word organic, I think a lot of us think immediately of organic vegetables and fruits that you see at the grocery store. But that's not what I'm talking about here. Organic is a substance that has carbon. Inorganic is a substance that does not have carbon. So you and I, since we are made up of almost 20% carbon, you and I are organic substances. Other organic substances would be carbohydrates, lipids, proteins. We'll talk about those in a minute. Inorganic substances would be anything that does not have carbon, such as water, H2O, hydrochloric acid, HCl, salts, bases. Anything without carbon is considered inorganic. Now, on the next 2 videos, you're going to learn about the different organic compounds that our body has: carbohydrates, lipids, proteins, nucleic acids, and each of them have their unique roles in our body.